All right, so let's get back started with example 2. We're going to do a little bit more appreciating with this problem. So let's go ahead and look at this first. It says, okay, number 1, WXYZ is a parallelogram. Okay, so this is WXYZ. Also know that when WXYZ, it's always in order. So WXYZ, you always go around the parallelogram, okay? It would never be like WXYZ. It's never going to be like that. It's going to go around. So you could say YZWX or XYZW, but it always has to go around, okay? So what we're asked to find is YZ, okay? So it's a parallelogram that opens the door to these 4 lovely theorems, right? So if they want us to find YZ, which is a side, which of these theorems will be used? And since we have a side, we're probably going to be using this opposite. Sides are congruent, right? And if you look, it gives us this information here, the variable is A. So we have to figure out what they want us to find YZ, okay, which is here. This is YZ. And the opposite side is right here, okay? So they're both in terms of A, so we know that these two are congruent to each other, right? Because if it's a parallelogram, the opposite sides are congruent. So let's see here. The first thing we have to say, and I'm going to make this a 0, is we have to say that we have a parallelogram. So parallelogram WXYZ. That opens the door to the 4 theorems, all right? So WXYZ, that is given. All right? Then, because of that, we can say that YZ is congruent to WX, right? Because if it's a parallelogram, then the opposites, that says opposite angles are congruent. That is a typo. It's a typo alert. Typo alert. Okay, where is my friend? Here is my friend, right here. So you're going to have to erase this in yours as well. Okay, so the opposite sides are congruent. That's what it's supposed to say. Okay, so these are congruent. Opposite sides are congruent. Then we're just going to have to change that format, right? YZ equals XW, definition of congruent segments. And then we have to substitute, but wait, we have to put in our given information. So I'm going to make a little arrow. I'm going to make a comma and then an arrow up here because I'm going to run out of room. We have to say that XW is equal to 6A plus 10. And we also have to say YZ is equal to 8A minus 4. And all of that is given, okay? All of that is given. All right, so now that is all of our given information. Then, since we stated that as the given information, now we can substitute that in. YZ, right, is 8A minus 4, and XW is 6A plus 10, just substitution. Now we're just trying to figure out what A is, right? So we're going to get the variables on the same side. We're using that subtraction property of equality there. 8A minus 6A is 2A. Just rewrite all that stuff. Then we addition property of equality, add 4 because we're trying to get the A by itself, right? So that cancels. We're left with 2A equals 10 plus 4 is 14. That's simplifying. And then we're still trying to get A by itself, so we're going to use the division property of equality, divide both sides by 2, right? And then we end up with, that's 1 times A is A, 14 divided by 2 is 7, okay? So we know what A is, right? But what is the problem asking? It's asking us to find YZ. So I'm just going to write down what YZ is, right? YZ is 8A minus 4. So that's here, YZ equals 8A minus 4. That's given. And then we just substitute that in. And then from there, we're just simplifying. So A is equal to 7. We substitute 7 in. We have 8 times 7 minus 4. 8 times 7 is 54 minus 4 is 52. So this is all simplify. All right? And that is our answer. That's how we found YZ. Okay? And make sure you look back on your notes as you're doing your homework and things, because this process can be a guide. So I hope that you guys, this whole process here, I hope that you guys are doing that on your notes. Okay, let's look at example 2B. So surprise, surprise, we have another parallelogram right here. This time we're supposed to find the measure of angle Z. Oh, parallelogram, that means it opens the treasure box of these 4 lovely theorems. Okay, so let's just take a peek here. We have all of this given information right here, and what does it want? It wants measure of angle Z. It wants to find this. What do you see? We have some sides, and we have some consecutive angles here, and what do we know? We know that if it is a parallelogram, then the consecutive angles are supplementary. So we're going to be using this theorem here, but we have to state our given information first. So let's go ahead and do that. The first given information is that it's a parallelogram, right? So we have a parallelogram, WXYZ, and notice WXYZ, it's in that order. Then we have to state this given information. Let's say, oops, sorry about that. We'll say the measure of angle W equals 18B minus 11, and the measure of angle Z equals 9B plus 2, and that is all given information. Now we're just going to state that these 2 angles are supplementary, because if it's a parallelogram, these are supplementary. So we have the measure of angle Z plus the measure of angle W equals 180. If it's a parallelogram, then the consecutive angles are supplementary. Perfect, perfect. And then we just substitute in, right, the measure of angle Z, that's equal to 9B plus 2. The measure of angle W is 8B minus 11. We substitute it in, and then we're just simplifying, right? We're combining like terms, so 9B plus 18B, that's 27B. We got 2 minus 11, which is negative 9. And then we're just going to